Good day to you, grade 12 learners. Welcome to today's mathematical literacy lesson. My name is Bernard Donko. This lesson is brought to you by the Northern Cape Department of Education in collaboration with Pagama Research and Development. Today we want to focus on measurements. So under measurement, we want to look at surface area. What do we expect for us to learn by the end of the lesson? You should be able to solve problems and complete given tasks, especially the ones in examination. You should be able to determine and calculate appropriate quantities of materials in order to complete tasks. You should be able to calculate the cost of materials needed to complete a task. You should be able to determine the required budget for a given task, as well as make choice regarding the cost and quantities in order to complete task. So what do we expect you to know by this time? Your knowledge about perimeter will be very important. Even the knowledge from grade 10 and 11 in terms of area and surface area, they will help a lot. So here we go. Let us start. We want to do a little bit of baseline assessment. We want to judge ourselves to see what do we already know. Mr. Bokwe is working as an intern at a company in Johannesburg. The company designs boxes and other containers for dairy products. He is required to work on a design for a juice carton as shown in the diagram. So here is the picture of how the dairy juice product will look like. And then this side is the dimensions. So we have the dimensions of the juice carton. We have the length 6.4 centimeters, the breadth 0.04 centimeters, and the height 10.5 centimeters. Take note, the dimensions of the base are the same as the dimensions of the top. That's a clue. The formula that we have to use is area equals length times breadth. So question number 1, write down the type of 3D figure that represents this juice box. 1.2, convert the side in meters to centimeters. All right, so we have 3 minutes. Can we do this quickly? We'll come back. Welcome back, learners. So here we have the first question, which says we must do what? Write down the type of 3D shape that we see there. And the shape is what? It is a rectangular prism. It is what? A rectangular prism. And then we are saying you must convert the side in meters to centimeters. So you see here, it's 0.04. Okay, it was written as centimeters, but it was actually in meters, which is what? 0.04 meters. We multiply that by 100, and that will give us 4 centimeters. So make a correction on that if you can. The value is 0.04 meters, not centimeters. That will allow us to convert it from meters to centimeters. Okay, now that we've gotten the baseline out of the way, let's look at some of the terminologies that we're going to use as we work with perimeter. The first one, perimeter is the total distance around the boundary or edge that outlines a specific shape. Or you can just say perimeter is the total distance around an object. That will be good enough for us to mark it correct. Remember, in the examination, we'll be asking you to define, we'll be asking you to explain. So you have to pause, write some of these definitions down so that they help you a lot. When we talk of area, we are saying area is the amount of 2D space occupied by a 2D shape, or the amount of space occupied by an object. That is what we call area. When we talk of a triangle, we are talking of a plane figure that is made up of 3 straight sides. So let's say you have a page. If you can fold it into 3 parts and you're going to get a triangle. When we talk of a rectangle, we are talking of a 2D shape that has got 4 sides. And how do we know it's a rectangle? 2 of the opposite sides are equal, and the other 2 are also equal in length. When we talk of a square, then definitely it means that all the sides are equal. All right. Circle, we are talking of what? A closed curve that is everywhere the same distance from the fixed middle point, and that's what you call a circle. Okay, how about diameter? I think by now you know what you call diameter. Is the line that divides a circle into two equal parts. What does it do? It divides a circle into two equal parts. Radius is half of diameter. So it's the same as the line that starts from the center to any portion of the circumference of the circle. That's what you call a radius. When we talk of a 2D shape, we are talking of a shape or diagram or a picture that has length and width only, meaning it has only got two sides. Then we talk of circumference. Whenever we speak of circumference, we are talking of the distance around a circle or the perimeter of a circle. So sometimes when we ask you circumference, we also imply that it is also the perimeter. We use perimeter and circumference interchangeably. Surface area. This is the area of all the exposed surfaces of a 3D object. So if you have got a box that has got 6 sides, surface area is the area of all those 6 sides. If you have a cylinder, surface area is the drum, the area of the drum, and the area of the 2 circles. Alright, so if we look closely for a box like this object here, when you open it up, you will see that it has got 6 sides. This is the top, this is the base. These are the sides. Can you see I have color coded them for you to know that each of the shape is made up of 2 same or similar sides. So the top and the base are the same, side and side, the front and the back, they are all equal. If you expand it, you will see here. Can you see the blue ones are equal or same size? Then the greenish ones, and then the other colors are also same color coded. But in the end, how many sides are there? There are 6 of them. So even though the surface area works with 3D shapes, the unit of measurement is still in squared units. So if you are measuring in meters, it's going to be meters squared. If you are measuring in centimeters, it will be centimeters squared. If you are measuring in feet or inches, it will always be squared because we are multiplying only 2 numbers. Okay, so in examination, the examiner most definitely will give you the formulas. So this is the formula for if the shape is a rectangular prism, like a duster. That's a rectangular prism. So you see that we have 2 of length times breadth, 2 of length times height, and then 2 of breadth times height. If the shape is a cube, you find that all the sides are equal. So it's going to be 6 times the side by side. How about if the shape is a cylinder? Then it will be 2 pi r squared. 2 pi r squared, remember pi r squared is the area of a circle. So the 2 is saying we have 2 circles, the top and the bottom. And then 2 pi rh is the area of the drum. I will explain to you as we do examples. Then I've explained to you that when you see L, that's length, B is for breadth, and H is for height. So we have talked about when the shape is a rectangle, when the shape is a cube, when the shape is a cylinder. Now we are talking if the shape is in the form of a triangular prism. Then the formula will be perimeter, if you want to find surface area, to be the perimeter of the base times the length plus 2 times the base. So here we're talking of what? The base area. This is the formula which the examiner will give to you in examination. So it's going to be S1 plus S2 plus S3 times the length plus B times H. Let me explain that. H is the height, S1 is the breadth, and then L is the length. So when we talk of S1 here, we are talking of what? Side of a triangle, which can be the base in relation to the perpendicular height, or S2 will be the second side of the triangle, S3 will be the third side. Well, that is a lot of information, but how do we put it into practice? First, take note of the following. It's very important that you remember that all the units must be the same. Please don't forget. For you to get marks about area and surface area, remember all the units must be the same. We use the radius when we are working with cylinders, only when the shape is a circle. The first skill that you need to master is to be able to visualize the 3D shape to say, how will the shape actually look like? And then you also need to look at the substitution into the formula. And then the last one, your surface area formula is generally very long, so you need a lot of accuracy. Let's put it into practice. If you look on the right side here, this is something like a juice box. So I'm asking you questions which can allow us to answer the questions and be able to use the idea of surface area to move on. It says the diagram alongside shows a typical juice box with dimensions. So we have the height is in 4 inches, the width is 5.08 centimeters, the length is 7.62 centimeters. What do you immediately notice about this shape, these values? You realize that the height is different. It is in inches, which means along the way we need to convert. So look at first question. It says calculate the height of the juice box if 1 inch is the same as 2.54. Like I said. 1.2, calculate the total surface area of the juice box in centimeters squared. You may use the formula, then the examiner gives you the formula. So let's quickly deal with these 2 questions and then we will come back. Can I give you about 5 minutes to attempt it and then we'll come back together? Welcome, learners. So let's look at the first question. We are supposed to convert. What are we converting? We are converting the 4 inches. So our focus is on the 4 inches. What do we do here? We need to use the conversion factor, which is 1 inch equals 2.54 centimeters. So what do? I multiply the 4 inches by 2.54 centimeters per inch, which is going to give me 10.16 centimeters. I've managed to change it, convert the value from inches to centimeters. Right, let's look at 1.2. Calculate the total surface area of the juice box in centimeters squared. So the first thing you have to do is to write down your values. Write down the length, the width, the height. As you write, you check whether all the shapes, all the sides are same unit. Can you see now we are using the length 7.62, the width 5.08, and then the height which we just converted, it is now 10.16. We are not using the 4 inches. So what do? We substitute the formula. Wherever we see L, we're going to write 7.62. You put your times. When you see W, you come and write 5.08. When you see L again, you write 7.62. When you see height, you come and write 10.16. When you see the width, which is what? 5.08, and the height, you substitute there. Once you're able to do that, you will see most definitely they are going to give you 2 marks already for being able to substitute correctly. Then what do? You press bit by bit, press this portion, you write your answer. Press the next portion, you write your answer. So can we give it a try? The first one says 2 into bracket 7.62 times 5.08 close bracket. I got 77.4192. You write it down. Then you go to 2 into bracket 7.62 times 10.16 close the bracket, and you're going to get 154.8384. Good. You write it down. So we have done this one and that one. Then we go to the next one, which is 2 into bracket 5.08 times 10.16 close bracket. You're going to get 103.2256. So all our numbers are correct. What do you do next? You press all of them and you're going to get a value of 335.4832 centimeters squared. So you find that this work will give you about 4 marks, if not more than that. Remember, it's even more than this because the examiner gave you marks for converting already. So already you have a lot of marks here. Now it is time for us to do some activities. I want you to practice and see if you can be able to do it. So the first question here, A chocolate bar is in the shape of a rectangular prism as shown in the diagram below. Use the information above to answer the following questions. Question 1. Calculate the surface area in centimeters squared of the bar 1 chocolate that needs to be covered with chocolate. You may use the following formula. So the examiner gives you the formula and says we are supposed to do what? We are supposed to calculate the total surface area. 1.2, to ensure that the chocolate bar stays fresh and lasts longer, they are wrapped in a special foil wrapping. The wrapping is 11.575% more than the surface area of the chocolate bar. Calculate how much wrapping is needed for 1 bar. So we are going back. We have 2 questions which need a lot of time and attention. So we are giving ourselves only 10 minutes. After 10 minutes, we must come back and discuss together. Remember, it is imperative that you try it on your own. The first question says, calculate the surface area. The examiner gave you the formula, so write down the formula so that you don't have to forget. Number 1.2, calculate how much wrapping is needed. So we have 10 minutes. After 10 minutes, if it's less than 10 minutes, that would be nice. Then we come back and discuss together. Welcome, learners. So let's look at our first question. The length is what? 128 millimeters. There it is. So we have to convert to centimeters. We are changing from where? Millimeters to centimeters, from small to big. So we divide by 10. We're going to get 12.8 centimeters. The formula that the examiner gave to you, you write it down. Like we did in the worked example, we are now making substitutions. So we take our length, which is 12.8, not the 128, times by the breadth, which was given to us as 2.5 centimeters, plus open bracket 12.8 times 1.5. Remember, we are now using the new value. We are not using the 128. Then we take the last one. Remember, we are only replacing numbers here. So it's going to be 2.5 times 1.5. Press the first one. Let us all check and see that we are going to get the same answer. 2 into bracket 12.8 times 2.5. Close bracket. You are going to get 64. All right. Plus, then we go to 2 into bracket 12.8 times 1.5. Close bracket. We're going to get 38.4. Good. Then we have the last one, which is 2 into bracket 2.5 times 1.5. Close bracket equals to, what's your answer? 7.5. So what do we do next? We add all the values. So we have 7.5, or let's start from the beginning. 64 plus 38.4 plus 7.5. Press your equal sign, and what does it give you, my learners? You're going to get 109.9. Then you put centimeters squared. Remember, it is still area. So you are going to get your full marks. You get a mark here, a mark there, and 2 marks for substitution. All right, let's go to 1.2. We are supposed to calculate how much wrapping is needed. So currently, the surface area is 109.9 centimeters squared. They are saying it's what? It is 11.75 more than the surface area. So what do? We find 11.5% more. That is going to give us 12.91. What do you think we are going to do with this? We are going to add it to the surface area. So remember, our surface area is already 109.9. We'll say plus 12.91. And that will give us 122.81. So remember the question again. Calculate how much wrapping is needed. So how much wrapping do we need? We need 122.81 centimeters squared. Very good on that. Here is another activity that needs your attention. Again, we are going to write and then we'll come back to reveal the answer together. It is very important that you try. It's very important that whenever the question comes, no matter how tough or difficult it is, you always attempt it so that you will know that you are doing the right thing. During the exporting process, the chocolate bars are packed into a refrigerated shipping container to ensure that they remain fresh. An example of a refrigerated shipping container is shown alongside. The area needed for the compressor of the refrigeration container is 2.59 meters squared, and I've highlighted it to you in red here. 1.31. Calculate the surface area in meters squared. Okay, the surface area in meters squared of the refrigerated container. You may use the formula surface area is equal to 2 into bracket L times width plus 2 into bracket L times height plus 2 into bracket width times height minus area needed for the compressor. Remember, the compressor is that machine which runs and keep the whole item cool. So here you have a work to do, and I hope that you get it correct. 1.3.2. The Epicon Marine Finish paint that is used to paint the containers has a spread rate of what? 8 meters per liter. You need it, so write it down somewhere. 8 meters per liter. Calculate the amount of paint required, rounded off to full liters, to paint the shipping container with 2 coats of paint. Again, you must highlight that portion. 8 meters squared per liter and 2 coats. 1.3. The Epicon Marine Finish paint is sold at 1,154.71 for every 5 liter can. Meaning when you take the 5 liter container, the price is 1,154.71. Calculate the cost to paint 10 shipping containers with the marine finish paint. So let's go. We have how many minutes? We have got 3 questions here. We need to give ourselves only 10 minutes, and after 10 minutes we try and come back to answer together. It is very important that you try it. So let's give us 10 minutes. We'll come back now. Okay, welcome learners. So let's look at the first question. The examiner says we should calculate the surface area of the refrigerated container. So what do? We substitute. That's why you see what I'm writing there. So I want us to substitute and write our answer down and see if we can get the correct one. 2 into bracket 6.05 times 2.44 close bracket is going to give me 29.524. So this one is correct. Let's go 2 into bracket 6.05 times 2.59 close bracket equals to 31.339. This is also correct. 2 into bracket 2.44 times 2.59 close bracket equals 12.6392. Then minus all these values, minus the area of the compressor. Remember, they told us the area of the compressor is what? 2.59. So let's add all our answers, then we come and subtract. 29.524 plus 31.339 plus 12.6392. That will give me 73.5022. So we must minus 2.59. That will give me 70.9122. So let's check. Did you manage to get these ones correct? If you didn't, I hope you are practicing. All right. So here we have, that's my 70.9122, and there is the correct answer. What do you do now? I want you to pause, write down the information that you received, and let's see if you get it correct. Let's go to 1.3.2. The paint has a spread rate of what? 8 meters per liter. We want to paint how many? 2 coats. So how do we attempt this one? Go back. What do we need to paint? 70.91. So here is your 70.91 meters squared. You want to paint it. So they are saying the paint which is sold is what? 8 meters squared for 1 liter. So every 8 meters squared, it needs 1 liter, and we need to paint 70.91. So what do? We take the 70.91 meters squared divided by 8 meters squared times 1 liter. That way the meter squared will cancel the meter squared. So let's see, let's divide it by 8 meters squared. That will give us 8.864025. So there we are. So now that we have this, this is how much liters we need for 1 coat. Remember, the examiner says we have to paint it how many times? Twice. So what do? We multiply our answer by 2, and that is going to give us 17.73 liters. Please do not forget, we cannot buy 17.73, so we rather round it to 18 liters. We need to buy more, because as we paint, whether with the roller brush or anything, some of the paint will get stuck there, and therefore we need to buy more. The more we buy, the more safer it is for us, because if we run short, then it's going to be a problem. So now we go to 1.3. Remember, the examiner says every 5 liter can is 1,154.71 cents. So they want us to buy the paint. Okay, so remember we have 17.73 liters, which we are going to buy 18 liters, by the way. We need to paint how many? 10 containers. So that would be 177.3 liters. So here is the problem. The paint, they only sell them in 5 liters, 5 liters, 5 liters. Therefore, we need to know how many 5 liters do we need. So what do? We take that 177.3 which we got, we divide it by 5 liters. That means we need to buy 35.46, but we can't buy 35.46. We have to buy full 5 liter cans. That's how you see that we are giving you 36 cans or 36 tins. Now that we know how many containers we need to buy, we go back and multiply that answer by the price of 1 can. We know the price is what? 1,154. So you see 36 times 1,154, we need to spend 41,569.56. That's how much we need for the container. Right. Let's go to our question number 2. Here is a Coca-Cola can. We have been given the height as 12 centimeters, the diameter as 6 centimeters. It says a Coca-Cola can cost 25.75, VAT inclusive. I hope we have done VAT already. Per dozen of cans to manufacture. Okay. The following diagram shows an image of an example of Coca-Cola can with dimensions as well as the net of a cylinder. So here is the can, and then when you open it up, this is the top, this is the lid, and then this is the drum, which we fold so that we can get the whole cylinder. 2.1.1. Calculate the surface area of the Coca-Cola can. You may use the formula 2 pi r into bracket r plus h, where pi equals 3.142. So my learners, let's go 3 minutes, and then after 3 minutes we'll discuss together. Let's go. Welcome back, my learners. So now we want to find the answers. Question 1.2, keep your answer there. We want to do 1.2 and then we'll add everything. 2.1.2, calculate the cost excluding VAT of the aluminum material that per can. That material that was used, how much is it? So now let us start. You go back, do 2.1.2 also. What is the total cost there excluding VAT? Because they said it's 25.75 VAT inclusive per dozen. So you have to know what's a dozen so that you can work. I'm giving you 3 minutes or so, my learners, for question 2.1.2. Let us work it out. We'll come and discuss together. All right, welcome back, my learners. So let's see our answers here. 2.1.1, we were supposed to calculate the surface area, but if you look into the question, the examiner gave us a diameter, and remember in our formula there's no diameter, so we needed to find the radius. So the 6 centimeters divided by 2 will give me a radius of what? 3 centimeters. Now we are going to use 3 centimeters in the formula. So the formula says 2 times pi times r, open bracket, r plus h. So what we have to do is just to substitute. There is the 2, there is the pi, there is the r into bracket, r plus 12. So let us work it out and see. I want to show you something quickly. So we are substituting our values. It's going to be 2 times 3,142 times r, which is 3, then open bracket, press 3 again, plus h. The value of h is 12, so it's 12. We close the bracket, and that should give us, write down the answer that you got, 282,78. This is a plus, not a times. 282,78, that is correct. Let's look at 2.1.2. You are supposed to calculate the cost excluding VAT per can. Cost per can. So we know we paid 25.75 for dozen. A dozen is 12. Half dozen, 6. So now that we know we pay 25.75, we divide it by 12. So let's check. So we have what? 25.75 divided by 12. That will give me 2 rand 14 cents if you round it to decimal places. Now we're looking for VAT exclusive, meaning the 2 rand 14 cents has already got VAT, but we don't want VAT. So what do we do it? We're looking for 100%. So times it by 100 and divide everything by 115, and that will give you 1 rand 87 cents. 1 rand 87. I hope you got that correct. Okay, now I have given you a different shape. We have worked on a circle, we have worked on a cylinder. Now we have also worked on the rectangle. Let's look at a triangle. The diagram below shows the dimensions of triangular prism chocolate. The chocolate needs to be wrapped in a foil wrapping that is 10% more than the surface area of the chocolate. Calculate the surface area in centimeters squared of the triangular prism chocolate. You may use the formula surface area equals S1 plus S2 plus S3, open a close bracket, L plus S times H. I have explained to you what each one means here. So question number 1, we have to calculate the surface area. Good. 3.2, we are supposed to calculate the amount of foil wrapping needed for the chocolate. 3.3, the foil wrapping that may be used is sold at a price of 40 rand per meter squared. Can you see now? The unit is different. Calculate the cost of the foil wrapping per chocolate if 1 meter squared is equal to 10,000 centimeters squared. So we have 3 questions, 10 minutes. Let's go. We'll come back and show our answers. Okay, welcome back, learners. So 3.1, we are supposed to find the surface area. So its formula is already given to us. What you do is to try and substitute the values. S1, the side, each side, can you see is 4? So there's 4 plus 4 plus 4. Close bracket times L, which is 1.5. That's the L, or the height, 1.5. I hope you can see that one. Plus, then we say we should have S times H. So what is S? Is 4 times the height of 3.5. Height of the triangle is 3.5. So let us press and confirm that our answer is correct. It's 4 plus 4 plus 4, which is going to give me 12 times 1.5. That will give me 18. There's our 18. Then 4 times 3.5. 4 times 3.5. That gives me 14. There we are. So 18 plus 14 is 32. How about 3.2? How did you get it? They said it's what? 10% more. So 10% more than the 3.2. So that's why you see that I'm pressing here 10 over 100 times 32. That will be 3.2. Once you get that answer, you add to the 32, because they want us to find what? The amount of foil wrapping that is needed. So 32 plus 3.2, that gives you 35.2. I hope you got that correct. Let's look at number 3, which involves money now. Calculate the cost of the foil per chocolate if 1 meter squared is equals 10,000 centimeters cubed. Okay, we need to wrap 35.2 centimeters cubed. So we take that 35.2 centimeters, we divide it by the same unit from the conversion factor. This is a conversion factor. So we're dividing same unit, and that's how you see me getting 0.00352. Then that we have the answer, we are going to multiply it by 40 rand. So 0.00352 times 40, that will give me 14 cents per chocolate. Meaning the cost to wrap one is what? 14 cents. So now it's time for you to take something home. And this time I have given you a very different shape. It says the following table shows an image of an example of the bright stand with the dimensions. Calculate the total surface area in meters squared of the bright drum to be painted with the heat resistant paint. You may use the following formula. I've given the formula. So for you to know and understand better, you should know that you are working for your own good, and therefore it is so important to keep on practicing even when you are on your own. And that is the reason why I'm giving the homework. Today we have learned about a whole lot of things, but specifically on surface area of various shapes. Please remember, you always need to look out for the substitution. Number 2, remember that you convert all the units before you attempt. Number 3, the surface area formula is usually long, so try to practice as much as you can. But the most important thing is that yours is to ensure all the values that you are using, the units are all the same. You should be able to substitute them, and once you use that, you're fine. Whenever we talk of radius, you should know that radius we use it when we are talking of a shape that is round. Well, in the next lesson, we'll be wanting to look at volume. We go closer of 3D shapes, because now we have talked of what? Surface area. So I am hoping that you don't miss out. Stay tuned for the other topics that are coming. Thank you so much for staying with us through this lesson. I hope you learned something much valuable. We will see you soon. Bye bye.